So this is chapter 9, linear inequalities in two variables. So we're going to start with just linear inequalities, go over to quadratic inequalities, and go from there. So if we are graphing a linear inequality, it is the exact same as graphing a regular line. The only thing that we need to be cognizant of is whatever they're using here. Okay, good. Just checking that my board is calibrated there. So then if we have 2x plus 3y must be less than or equal to 0. This less than or equal to indicates solid line. Now all we have to do is we can either use our x-intercept and y-intercept to plot it, or we can change it into the basic linear form. I'm going to do that. So this becomes 3y must be less than or equal to negative 2x. Divide by 3. Divide by 3. Y must be less than or equal to negative 2/3 x. Then I know because of the way this looks, there's no y-intercept here, that I have my y-intercept is at 0, 0. Then my slope tells me to go down to 1, 2 over 3, down to over 3, down to over 3. And then if I want to get some points on the other side of the line here, I go up to over left to the 3, up to over left to the 1, 2, 3. 2, 1, 2, 1, 2, 3. Perfect. Okay, and then I'm going to draw my solid line. Remember, it has to be a solid line, and then once you have that, you need to do a test point. And this will tell us which region is our solution region. Now, usually we do a test point of 0, 0, but we see that as on the line, so that's not a good point. So the next one that I would choose is I would choose 1, 1. So my test point is 1, 1. So then I go 2 multiplied by 1 plus 3 multiplied by 1 must be less than or equal to 0. So is 5 less than or equal to 0? No. So it's not this region that we shade, but the other region. So that would mean that everything over here would make this statement true. So if I did a check, and I said, okay, what if I chose -1, -1? So 2 bracket -1 plus 3 bracket -1 must be less than or equal to 0. We can see that that would be -2 plus -3 less than or equal to 0. And -5 is less than or equal to 0. So we know that guy works. Okay, let's go on to the next one. We have 10x minus 5y must be greater than 0. So this guy tells us we're looking at a dashed line, or stippled. So then 10x is greater than 5y. 2x is greater than y. Okay, so then we know again, because there's no b value here in the mx plus b, that their y-intercept is at 0, 0. My rise over run, up to over 1. Down to over 1. Okay, and then we draw our dashed line. Once you have that drawn, you need to do a test point. We can choose 1, 1 because that is not on the line, that is right next to it, so test point. (10 multiplied by 1 minus 5 multiplied by 1 must be greater than 0. So then 10 minus 5 greater than 0. 5 is greater than 0. So then we would shade in this side. just like that. Okay? That's it. Graph it exactly like you would a linear, just make sure to pay attention to the sign. Because we want to be able to read these too. So if we look at this, we see that our y-intercept is 1. And then our m is we go 1, 2 over 1. So 2 over 1. We know that this should be y something 2x plus 1. So then we need to see if we need this to be greater than, if y needs to be greater than this or less than this. So let's try. So if we said y must be greater than 2x plus 1, and we test 0, 0, so 0 less than 2 multiplied by 0 plus 1, and 0 must be greater than 1, that's not true. So if we had this guy, that said, okay, we would not shade the side with 0, 0. So now, did I shade the 0 side in this? No, I shaded this side. So this is true. Whoops, that's a 2. I don't know why I wrote a 2. Y must be greater than or equal to 2x plus 1. And that's because the solution region is on this side of the graph. And lastly, we have a word problem here. Suppose that you're constructing a tabletop using aluminum and glass. The most that you can spend on materials is $50. So I can spend $50 and I can spend under $50. I can spend up to $50, including $50. Laminated safety glass costs $60 per meter squared, and aluminum costs $1.75. Okay, so 60x plus 1.75. Why? You can choose the dimensions of the table and the amount of each material used, find all possible combinations. So all you would need to do is graph this, and we're going to graph this using Desmos so you guys can see. So you can see here that I have it plotted. This is the equation that we chose. We can scroll out and we can see that we would have our x-intercept here and our y-intercept about here. So then what we need to remember is that we're not going to care about when this is negative, right? We're only going to care about when it's positive. So our solution region will be limited. I even think there's like a way to edit it properly, but we can see that later. We can see that this has the proper line that we need to use. So if I change this, it'll give us our dashed line automatically. So if you want to see this graphically to confirm that you've done it correctly for one of these guys, definitely use Desmos to check it out. And that should be everything. You guys should be good to go on to the assignment.